Hi everyone, this is Sindhuja Reddy from Mlritm College from Computer Science and Data Science. Today I am going to discuss about already we discussed the topic Introduction to Finite Automata, what is symbol, what is alphabet and what is language and how to construct DFA. So yesterday we discussed only five steps to construct a DFA. In that we discussed the starts with, ends with and substring. So today also I am going to discuss only the substring A, B, B. So very important topic, that is DFA, how to construct DFA. In this we have the five types: starts with, ends with and substring, length and divisibility. So here the starts with, it uses the dead state. Dead state means the input string should pass every state until it reaches the final state. So the input strings are used by the every state. So here yesterday we discussed the starts with 0, 1. Suppose the starts with it is start with A. Suppose suppose it is started with B. It is started with B or A. So I am taking A. So how many states we have? We need to take the formula, that is n plus 1. How many variables they gave in? Only 1. 1 plus 1 is equal to 2. So we have the two states, that is Q0 and Q1. Here the Q0 is the initial state and Q1 is the final state. So the starts with languages are L is equal to A, AB, AAA, ABA and so on. Because here the length is not given, so we can write infinity. So here from the starting is single digit A. It starts with A and it reaches to the final state. And A, B. A, the condition is starts with, and we have to use A starting and the B, n number of B's, it can be end. End low, we can have n number of B's. So at starting we need to give the condition A. And A, self loop A, again it will goes to the Q1 only. So A. Next A, B, A. So here according to the DFA, every state uses the same input strings. Input strings should pass both A and B to the every state. So already Q0 uses the A. So now it has to be use the B to the dummy state. B to the dummy state. So next problem, ends with. Already we discussed the ends with AB and AB. If it is AB is available, we need to use backtracking. For ends with, we use backtracking. So next one is substring. They given the condition sigma is equal to A comma B and the substring is A, B, B. The condition is A, B, B. So here we need to construct DFA. First we need to write the language. A, B, B. Substring means prefix or suffix, means the ABB should contain before the string, after the string also. So ABB, AABB, ABBA, ABBB and so on. So we have three variables. So what is the formula to know the states? That is n plus 1. How many variables are there? 3. 1, 2, 3. 3 plus 1. 3 plus 1 is equal to 4. Any states? We can say 4 states. Q0, Q1, Q2 and Q3. Here Q3 is the final state, Q0 is the initial state. So first string is A. When the A moves, the cursor will be at Q1. Next B. Next B. The 3 digits completed. Next we go to the AABB. A. One more A we required. The condition is ABB. It can be prefix or the suffix. Prefix is before the string, suffix is after the string. So before the string is A, AABB. Next, ABB, ABB, A, ABB, A. In between also we can use the substring ABB, ABB, A. Next, ABB, B, ABB, and here the condition is the DFA. Every state should use the input strings, both input strings. So here the Q0 uses only single A. So here also we can use dummy state B. So from here the Q2 I am taking the backtracking A. So whenever we are using the substring, we can use the dummy state and we can use backtracking also. Overall, we have to know that we have to deal with the condition. The condition is ABB. The substring is ABB. So ABB can be prefix, suffix at the middle also. Whenever we are giving A to the next before state, it is not disturbing the ABB. So we can use backtracking also. So hope you understand what is substring. So here the next is the construct DFA, which accepts all the strings over an alphabet. Sigma is equal to A comma B exactly 2s. Exactly 2s. So exactly 2s is only in the string. It requires only exactly. They are saying exactly 2s. So exactly 2s means the language is AA, ABA, ABBA and so on. Means here we have only exactly 2A's. Exactly 2A's. So exactly 2A's means the string contains only 2A's with combination of B's also. Don't think that exactly 2A's under the B's will not included. B's also included, but n number of B's we can use. But A's should be only 2. So now exactly 2A's. So how many states we need to use? 2 plus exactly 2. 2 plus 1 is equal to 3. So Q0, Q1, Q2. So A. The A should be anywhere. So only it has to be exactly 2 A's. So at starting I am giving self loop because at n number of B's we can use in the DFA. Whenever we use the exactly 2 A's, they are saying exactly 2 A's means only 2 A's they need. N number of B's we can use. So exactly 2 A's and n number of B's. But condition is DFA must use 2 input strings. So Q0 uses A and B, Q1 uses B and A. So Q2 does not use that one. So here self loop I am giving B because the condition it is only exactly 2 A's. So from here I am sending A to the Q5 which contains no value, which contains no value. So A comma B, I am giving A to the dead state. So the next problem, everyone knows, yesterday we discussed about the transition table also. The row should be state and the column should be the input string. So whenever we are performing the input string, where it reaches, that should be entered into the table. The next one, construct DFA which accepts all the strings over an alphabet. Sigma is equal to 0, 1. And the length of the string, here the length should be, length of the string is 2. Length of the string is 2. So already they mentioned the string length is 2. First we need to write the string. First we need to write the string. The length of the string is 2. Means AB, BA. String length enta? We need to use only 2 with the combination of A and B. AB, BA, AA, AA and BB. Any possibilities? AB, BA, AA and BB. With the length of the string, we have only these 4 possibilities. Now we need to find out the length. N plus 1. N plus 1. 2 plus 1 is equal to 3. How many? 2 means we have the length 2. So 2 plus 1 is equal to 3. Q0, Q1, Q2. So Q0, Q1 and Q2. So here the initial is Q0 and the final is Q2. So A, B. A, B. Next, B, A. Here we don't need to use self loop because the self loop uses, it says number of A's and B's. So it is greater than 2, it can be applicable. But here the given condition is length of the string is only 2. So we don't have to use self loop. A comma B, B comma A and AA, BB. So the strings are completed. Next we need to check the DFA, complete DFA in a column. So we need to check that complete DFA or not. So here I am checking AA. Complete DFA, Q0 uses the AB, Q1 uses the BA. So both is completed. For what about Q2? Shall I give self loop? No, because the size they given. The size is they given. The size is 2. So we need to use here dummy state. To this we can send A comma B. The self loop also we can use for the QPy because it does not contain any value. So hope you all understand this class. So today we discussed the 3 things, that is substring, exactly 2 A's and length of the string. So the next last topic is divisibility by 3. Divisibility by 3. So divisibility by 3 means we need to write the language L is equal to 0, 3, 6, 9 and so on. Divisibility by 3 means the language should be in the form of 0, 3, 6, 9 and so on until infinity, which are divisible by 3. So here whenever we are doing the divisibility, first we need to make a table. The table contains binary numbers, decimal number, binary number, remainder and state and state. So binary number of 0, decimal number of 0 is 000. The remainder is 0. When we are dividing with 3, it will get 0. Means whenever it gets 0, the state is Q0. Next, 3. So 1 I am writing 0. We need to write decimal number 0 to infinity. 0, 1. 0, 0, 1. Whenever we are dividing with 3, it will get 1. So it will goes to the Q1. Next 2. 0, 1, 0, 2, Q2. Again 3, 0, 1, 1. 0, 1, 1. So the remainder is 0. Again it goes to the Q0. 4, 0. What is the decimal number of, what is the binary number of 4? The binary number of 4 is 110. Binary number of 4 is 110. It will get Q1. 5, 1, 0, 1. 1, 0, 1. 1, 0, 1 is 1, 0, 1. 1, 0, 1. It goes to the Q2. 6. Again 6, 0, 1, 1. 1, 1, 0. 6 decimal number is, binary number is 110. We get 0, remainder Q0. Here whenever the 0 appears, the cycle is repeating. Means how many states we have? Q0, Q1, Q2. Q0, Q1, Q2. So here now only you don't have to decide what is final state. So first we need to draw the diagram. Transition diagram. First one, the decimal number of 0 is 000. It is going by to the Q0 state. Q0 state. So Q0 state, how we can write? It can be used by the self loop 0, which can accept all the zeros. It is a final state which can accept all the zeros. It is known as a final state in divisibility by 3. So next 0, 0, 0, 0, 0, 0, 0, and it is going one where self loop means itself. So 0, 0, 1. It is going to the Q1. 1, it is going to the Q1. Next 0, 1, 0. It is going to the Q2. It is going to the which state? Q2. Next 0, 1, 1. 1. The cursor is at Q1. From Q1 it is going to the state Q0. Q0. Next 1, 0, 0. It is again from Q2. The cursor is whenever we are taking 4 decimal number. 4 decimal number 1. From Q0 it goes to the cursor Q1. Q1 to 0 it goes to the Q2. The cursor is at Q2. From Q2 it is moving back. From Q2 it is going to the Q1. So backtracking 0. Next 1, 0, 1. It is going to the Q2. So self loop 1. Self loop 1. Whenever in the divisibility by 3, whenever the last state get self loop, the process ends. Once stop the process and check it is complete DFA or not. So the complete DFA, how you will check? Every input string should use the both in 0 and 1. Q0 uses the 0 and 1. Q1 uses the 0 and 1. And Q2 uses the 0 and 1. This is the divisibility by 3 diagram. So it is so easy. First write down all the decimal numbers 0 to 9. So 0 to 9. So decimal after completion of 0 to 9, you need to move to the next column, that is binary number. So here the 0 binary number is 002, 1 is 001 and 2 is 010, 3 is 011 and we should divide this one with the 3. So whenever we are dividing, we get this remainder 012. 0, 1, 2. After 2, the cycle is repeating with 0, 1, 2. So here the cycle is repeating with 0. So here we need to mention the states also, Q0, Q1, Q2. Again, if you got 0 here, again it will be with the Q0 only. Next, we need to check where it is moving. With triple zeros, it is going to the Q0 only. That's why we are giving self loop, which is accepted all 0. It is known as a final state whenever we are discussing the divisibility by 3. Next, 0, 0, 0, 0, and it is going 1 to the Q1 state, 1 to the Q1 state, and 0, 1, 0. It goes to the Q2, 0, 1, 1. It is going to the Q0, and 1, 0, 0. It goes to the Q1. Like that, you need to check, and until the process, the last state get self loop. Whenever the last state gets self loop, you need to check it is complete DFA or not. If you are checking whenever the Q2 appears self loop, so self loop, and you need to check whether it is complete DFA or not. If you are checking here, it does not uses 0, 1, only it uses the zeros, 2 zeros. So DFA does not contain multiple states. One can't move from one state to another state say with the same input strings. So it has to be compulsory. It has to be different states. So whenever it is complete DFA, your process is correct. Whenever it is not complete DFA, by getting the self loop to the last state, your process is wrong. So again, you need to do the same process. So thank you.